Hello everyone, MJ here. Hope everyone's doing well. I do need to apologize a little for my, well not a little, but for my sort of lack of presence on the site last week. I was away doing some training for the last 2 weeks, so was not fully engaged as I had wanted to. I apologize for that. But Charlie did step in and reply to your disinfection scenarios, and I think he did an excellent job. I think you guys did an excellent job too. Boy, I am impressed with how you thought things through, and yeah, great job. Really good. Okay, so this week we are jumping into water sampling procedures. So by the end of this week's session, our objectives are that you will have an overview of water treatment plant process control monitoring, understand the why, what, where, and when of water distribution system sampling. You will explain collection techniques for samples for VOCs and coliform bacteria, that's volatile organic compounds. You will understand water sample holding times. You will have completed a chain of custody form and then understood the key components of lab results, including some unit conversions. So let's take an overview of the assignments. There are 4 this week, but they're not all really heavy or won't take a lot of time, I don't think. And some are pretty enjoyable, viewing some videos and just posting to a forum. The first one, I think probably the first one is the most involved, and it involves looking at monitoring and sampling points and giving your input about where to sample what. And the website will explain more in detail. Assignment 2 is which kind of sampling would you prefer to do, and that, as I mentioned, is a viewing several videos on water sampling by American Water Works and several others that are really excellent. And then just to ask you which you would prefer to do. And third would be the importance of the chain of custody. You'll have an activity, an actual scenario of some testing and retesting that needs to be done for bacteria violation. So you'll read the scenario and then it should all be in the directions. Let me know if it's not clear. Then assignment 4 is what's in a water quality lab report. And this one is, I direct you to a website that has their water quality reports up listed. And so I just ask you to review, look out for some data, look out for some things that are inconsistent or some trends that you may see, and then ask you to post some comments about that. So I hope those are clear. Get back to me if they're not. Okay, so why sample the water? Well, this probably is not news to you. We've talked about this several times. It's required by the Safe Drinking Water Act for primary and secondary contaminants for preserving human health and safety. And there is a handy little book called Water Quality Sampling Guidelines by AWWA for distribution systems, if you should want to order that by yourself and use it. It's pretty good. And then one of the other reasons we sample is that it helps us make treatment decisions based on our sampling data. Pretty easy to understand that. So what are we sampling for? The primary, the Safe Drinking Water Act contaminants, and the secondary. Again, microorganisms, disinfection byproducts, inorganic, organic, and radionuclides. And then the secondary contaminants from safe drinking water regulations are these that are listed, and then there's a list here to the EPA site to look at their how they list their contaminants, in case you want to. So, process monitoring and control point. Process control monitoring and sampling. So on page 463 of the textbook, you will, I'm gonna let you read most of that, but these are the points that they touch on. Types of samplings, what kinds of sampling devices to use, and process control monitoring for each step in the treatment plant. right around pages 529, you'll see the implant sampling. That will help you with the assignment number 1 that you have. And then figure 10.1 is the actual figure that you will be using for that assignment. It shows the sort of the summary of the process monitoring guidelines and sample points. So, what are some of the commonly monitored functions? And these are in the textbook as well. Flow, level, water level, chlorine residual, turbidity, pH, weight, pressure, loss in head, sludge density, conductivity, and temperature. Types of samples. Again, referring to the text, page 530. There are 2 typically used: a grab sample, which uses clean glass or plastic containers, typically used for water not flowing continuously, and the type of water where the characteristics are somewhat constant, and also for water quality indicators that change with time, such as gases, coliform, temperature, pH, chlorine residual. And now composite samples are usually for a situation where water is flowing pretty rapidly, so its quality is changing rapidly. It is not used for bacteriological testing, and typically the samples need to be controlled and kept at 4 degrees C. Continuing on in that same section, you'll read more about automatic sampling devices. They do save time, but they are more costly. And of course, they would have potential operational difficulties, functions, mechanical or otherwise. Manual. Dippers are used. It's basically it's a wide mouth on a long handle, so you can, in case you're reaching over a bridge or over a pond or a reservoir, you can just hang over the edge and dip in. Weighted bottles. The lower bottle is, you lower the bottle to the desired depth, and then you remove stopper, and then fill it up. And then hand-operated pumps. They are used at velocities to avoid sedimentation. Now, our first location of water quality process control testing is in the area of coagulation and flocculation. And of course, jar testing is the most important. You can follow along and read in page 129 in the text. And so the types of indicators monitored at this point are turbidity, alkalinity, chlorine demand, color, odor and appearance, pH, and temp. And you can sample at the raw water intake, flash mixer effluent, or the flock basin effluent. The next location for process control checking is in the sedimentation. Pages 183 and 84 in the text. What's typically taken is turbidity, often several times in an 8-hour shift. They are to look at flow rate controls, and a higher rate would mean a less efficient sedimentation. Temperature, less frequent for stable conditions. You wouldn't need to test as frequently when things are running pretty stable. And can be grab or continuous, and they are typically taken from the flock basin effluent or the settled water itself. The next location for process control testing would be in the filtration process. Typically, turbidity is tested, of course, and inline continuous testing is best. And other operational indicators during that point are head loss buildup and filter effluent color. So, you can see this last comment at the bottom of the page was for when this was an in-class lecture. But if you do have questions, of course there's a forums to ask questions. I do apologize again for not being able to do this in the interactive lecture mode that we wanted to do, but we're hoping we're sort of making this the best that we possibly can with the use of forums and email for questions. So next is distribution system sampling. Now we have looked at this City of Santa Rosa's monitoring program and large water system back T site sampling plan. We used it back in, I think, under the regulations and admin session, where you kind of went in and did an overview activity of what is included in 4 of the sections. Well, now we're going to go just a little bit deeper with this and actually use some of the requirements for in one of our assignments. This website at the bottom, the CDPH, is where you can find out more information about criteria, what needs to go into a system sampling plan. So, for the coliform sampling plan, every water system should have a written coliform sampling plan, even if a lab collects the sample. And that's exactly what we're looking at for Santa Rosa's. That's their plan, their coliform sampling plan. It should include the following basic elements: a brief description of coliform sampling requirements, a list of routine and corresponding repeat sample sites, a rotation schedule of sample collection procedures, and a distribution map showing locations of water sources, storage facilities, and sampling locations. And this slide right here is taken from their sampling plan. And this is their standard monitoring plan for stage 2 disinfection byproducts. All right. Now, when should I sample? The frequency will depend on the population and what's being sampled, based on odor or taste complaints. And for positive coliforms, the sampling must be repeated, and we'll go into that in a slide or two, and also that will be part of your chain of custody activity. You will be working with some positive coliforms and doing some retesting, and then writing the chain of custody form for that retesting. And then there are also special cases for coliform testing anytime there's a well repair or construction, when there's new water mains being constructed, they have to be tested and then flushed, and that before they're put into service. And also if there's operation, maintenance, construction, and repair on storage facilities, that same high level of chlorination, and then repeat sampling after that. And then if the system pressure drops below 5 psi. Now, holding times, you can see more on that on page 34. The shorter the time between collecting samples and analysis, getting them to the lab is the best. They are required and laid out by the Department of Public Health and the EPA, under the Safe Drinking Water Act. The point is to preserve these samples, and some parameters like chlorine and temperature need immediate or field tests. And you should always use blue ice. Regular ice can freeze the sample or can melt and contaminate the sample. So this is very important. Use that blue ice. So, types of coliform samples. Since I only have 15 minutes and I'm almost there, I'm going to end this session right now, and we will pick up again with types of coliform samples in part 2. Thanks.